Okay, class, what we're talking about today, guys, is how to find the space inside of a triangle, aka the area of a triangle or space inside of a triangle. It's a two-dimensional space figure. Let's turn in to the objectives page. Um, First and foremost, we'll probably skip it, but first objective, recalling the concept of area. I just kind of talked about that. Area is the space inside of a two-dimensional space figure. Second objective, proving why the area of a triangle is one half the area of a parallelogram, or a rectangle, if you will, or a square, by the way. And then third, how to finding and using the area equation for a triangle. Okay. I'll let you come to this if you want to and think about it and take notes on. I just want you to recollect what you think it means, um, what the definition of area means. The bottom line is this: the space inside of a parallelogram, um, or actually, even if we want to, since we covered that yesterday, and I'll draw it, doesn't matter. If we take, that's a square, I don't like that. Um, if we take a rectangle, okay, and we'll call it rectangle A, B, C, Q. See, gotcha. It's a rectangle, okay? So what we had discussed in 8.3's lesson is that um, the space inside of a rectangle can be found using area equals base times the altitude, right? Now let's think about this. If I make a diagonal inside of this rectangle, start at any vertex you want, go to the opposite vertex, and then we'll notice that there's two triangles that fit inside of a rectangle in this case. And so if there's two triangles that fit inside a rectangle, and up here, the equation or formula used to find the space inside of a rectangle is area equals base times altitude, but there's two triangles inside of one rectangle, and I then ask you, well, what must be the area of this triangle in relationship to that original rectangle? Well, I'm hoping you would say, well, the area of that red triangle is half that of the area of the rectangle. Correct. So what do we do to find the space inside of that triangle or area of that triangle? We're going to take the equation for the area of the rectangle, area equals base times altitude, and then cut that in half. So area equals base times altitude divided by 2. So it's very close to the equation of the area of a rectangle, area equals base times altitude. However, the area of that red triangle has to be half the area of the rectangle. Let's put this into practice. And if you want to think of it this way, example 1, find the area of each triangle. Let's think about it since we've already covered rectangles. If we actually create that rectangle we're talking about, see the space inside of this rectangle right here, from 8.3's lesson, is going to be area equals base times altitude. Well, that's going to be area equals the base length 10 times the altitude 6. Okay, well, that would be the area of that rectangle in black would then be 60 square centimeters. So the area of the black rectangle is going to be 60 square centimeters. But we're not trying to find the area of the rectangle that I just created. We're trying to find the area of this triangle, which is half of our answer. So we're going to take that and divide by 2. So the area of this triangle has got to be 60 centimeters squared. Okay? Excuse me. So the area, I'm sorry, so the 60 divided by 2 is 30. So the area of this triangle is going to be 30 square centimeters because half of 60 is 30. Okay, the first and foremost, the thing I want you to realize is that the formula we're using to find the space inside of a triangle, or utilizing this equation to find a dimension of the triangle, is this equation here. Okay? What I want you to know in example A is that the base length is 10. And what I need you to start realizing is, where's the altitude always going to be? The altitude, maybe you call it the height. The altitude is the segment that is always perpendicular to the base. And in this case, the altitude of the triangle is one of the legs of the triangle. Okay. Let's go on example B. So how do we find the space inside of this triangle? We're going to take the base length times the altitude divided by 2. Well, the base length, okay, the challenge for students is identifying what's the base length and what's the altitude. Well, the base length is 8, and the altitude is found by finding the segment that is perpendicular to the blue segment. Well, the segment that is perpendicular to the blue segment is the green segment, and therefore 5 is the altitude and 8 is the base. So the space inside this triangle is going to be 5 times 8, and then divided by 2. So the space inside of this triangle is going to be half of 40, and the space inside of this triangle is going to be 20 square feet. Now, some students are accustomed to and like utilizing the formula for the area of a triangle written like this: 1/2 base times altitude, which is the same. These two formulas or equations are equivalent. So whichever one seems easiest for you, they're two and the same. Now, in example B, I want you to notice that the altitude of the triangle was not a leg of the triangle like in part A. The altitude of this triangle was actually inside of the triangle. So often students struggle with, well, where is the altitude of the triangle? Like in example C, if you were asked to find the space inside of the shaded blue triangle, first and foremost, you would identify the base length 15. But in this case, I need you to realize that because this is an obtuse triangle, the altitude is exterior to the triangle. So it's not in, the altitude is not inside the triangle here. The altitude is not a leg of the triangle. The altitude is outside of the triangle because this is an obtuse triangle. So the space inside of this shaded blue triangle is 1/2 16 times 15. Okay? So 1/2 of 16 times 15. We figure out what 16 times 15 is. Okay? 6 times 5 is 30. Carry the 3. 5 times 1 is 5 plus 3. 8. 6 times 1 is 6. 1 times 1 is 1. Add 0. 14. 4 carry the 1. 240. So the space inside of this triangle is going to be half of 240. So the space inside that shaded triangle is going to be 120 square centimeters. I'll leave example D for you if you want to practice that concept. So again, the altitude of a triangle can be one of the legs of the triangle. It could be inside the triangle, or it could be exterior to the triangle. In example 2, it says find the missing measurements. So we need to first understand what type of polygon are we working with. We're working with a triangle. So you say, okay, we're going with base times altitude. That'd be the area of a rectangle or parallelogram, but we're dividing by 2 because this is a triangle. So what's our given information? Well, we know the area is 63 square centimeters, so we have to substitute 63 in for the area. So now we got 63 equals. Do we know the base length? Yes, the base length is 14. So it's going to be 14 times the altitude. Do we know the altitude? No, we're looking for it. So we're solving for A. Of course, it's a triangle, so divided by 2. So to solve for A, the inverse of dividing by 2 is multiplying by 2. So those 2's cross cancel. So now we're going to double 63, which is 126, equals 14 times A. The inverse of multiplying by 14 is dividing both sides by 14. And then we should get, 126 divided by 14 has got to be, it's got to be 9. 14 times 9 is 126. So the altitude length is 9 centimeters. 126 divided by 14 is 9. Okay, let's look at example B. We know the area. So we're going area equals 1/2 base times altitude, space inside of a triangle. We know what the area is, so we're going to substitute 39 in properly. It's the area equals 1/2 of the base length. The base length is 13, okay, times the altitude. What segment is perpendicular to the base? That. So we're looking for the altitude. Not always looking for the altitude, by the way. That is 13 times A. Sorry about the spacing there. Let me rewrite that for you. So we have 39 equals 1/2 of 13 times the altitude. So if you want to rewrite the triangle equation this way, next thing I would do is divide by half. You could also multiply both sides by 2. Okay, I want to show this because a lot of times students will say, well, 39 divided by half, our answer's got to be smaller. But wait a minute, we're dividing by 1/2. So if we're dividing by 1/2, our answer better be bigger than the numerator of 39. In fact, when we're dividing by 1/2, we better double 39. So it's got to be 78 equals 13 times a. Divide both sides by 13. We're going to get the altitude of this triangle. It's got to be It's got to be 6, right? Sorry, I was doing that mental math. I'm sorry, my brain's struggling. 6 times 13 is 78. Okay, so the altitude of this triangle is 6 inches. Okay, in example 3, it says the area of a triangle is 24 square inches, and the length of the base is 8 inches. Find the length of the altitude. Okay, so it's a triangle. Okay, so we're going base times altitude over 2, or area equals 1/2 base times altitude. Either one is fine. We know what the area is. The area is 24 square inches, so substitute properly. So we get 24 equals. We know the length of the base is 8. We must be looking for the altitude. By the way, we're always not looking for the altitude. Maybe we're looking for the base length, but the process here is the same in those scenarios. Inverse of dividing by 2 is multiplying by 2. Okay, so now we got a double 24, which is 48. 8 times a, inverse of multiplying by 8 is dividing by 8. And so the altitude has got to be 6 inches in length there. Okay? Hopefully this helps. Thank you for joining us, talking about the space inside of triangles.